All right, starting the benchmark review. Give all the possible names for the ray shown. All right, so here I have this ray here. All right, so I need 2 points to name the ray, and I always start the ray with the endpoint here, R. All right, so the ray passes through Q, keeps going, so I could call it RQ. Or starting again at R, the ray also passes through P. So we could call it ray RQ or ray RP. Using the diagram, what is wrong with saying angle E is a right angle? Well, we have this point E here, and you could be talking about either angle here. You don't know which one you're talking about, though. So you would just say angle E is not clearly defined. That's one way of describing it. There's many different ways. All right, write the converse of the following statement and determine if it is a true statement. If 2 angles are adjacent, then they share a common vertex. All right, converse just means I'm switching these 2 components. So if 2 angles share a common vertex, then they are adjacent. Okay, now is this statement true? Well, come up with an example where 2 angles share a common vertex, but they are not adjacent. So look at angles 1 and 2. They share this common vertex here, but are they adjacent? No, they are not. Because in order for them to be adjacent, they have to share a side in common. And these are the sides to angle 1, and these are the sides to angle 2. There's no overlap. So they are not adjacent. So the answer is false. The converse is false. All right, another converse problem. Write the converse of the following statement and determine if it is a true statement. If 2 lines are perpendicular, then they intersect to form a right angle. So you're taking these 2 components and you're switching them. If 2 lines intersect to form a right angle, then they are perpendicular. Okay, is that true? Well, here's 2 lines, they intersect to form a right angle. Well, yeah, they're perpendicular then. That's true. There's no other way around that. If 2 angles are complementary, then they are both blank angles. Well, the 2 angles, x plus y, have to add up to what? 90. So definitely both of these angles have to be less than 90, which makes them acute. That's all there is to that. Done. If a linear pair of angles are congruent, then they must be blank angles. Well, here I have a linear pair, and they're congruent. So if they're congruent, this is what's going on here. They're the same measurement, and the only way they can be the same measurement is if they both measure 90. All right, for a linear pair. So that means these angles are both right angles. Find the value of x given measuring angle 1 is 6x minus 5, 2 is 4x, and this whole thing is 120. Okay, so I know measurement angle 1 plus measurement angle 2 will add up to 120 degrees. So I have 6x minus 5 plus 4x equals 120. So I have 10x minus 5 equals 120 plus 5. So I have 10x equals 125. divide by 10, and x is equal to 12.5. All right, find the value of x given. We have to use the same diagram as before in problem 7. So I know measurement angle 1 plus measurement angle 2 equals 114. So I have 9x plus 6x plus 4 equals 114. So I have 15x, and I'll subtract 4 here, equals 110. Divide by 15. And x goes in there how many times? It goes in there 7 times. And what's left over? Well, 7 times 15 is 105, so it's going to be 5/15, or 7 1/3. Done. All right, in the diagram, COE plus AOE is equal to the measure of what angle? Well, that would be this whole thing then, which is angle AOC. We could also call it angle COA. All right. Either one is correct. All right, in the diagram AOC, here I have AOC, AOC, and I'm cutting away DOC, and that leaves me with what angle? That leaves me with this angle here, the green angle. So that's angle AOD, or angle DOA. Right. Both are correct. Ways of expressing the answer. Going on to 11. All right, in the diagram, SU is the angle bisector of TSV. All right, angle bisector, so those are both the same. And says measure angle 1 is 3x plus 7. Measure angle 3 is x plus 3. What is the value of x if the measure of RSV, this whole thing, is 82? Okay, well, I know that measure angle 1 plus measure angle 2 plus measurement of angle 3 is equal to 82. All right, measurement of angle 1 is 3x plus 7. Measurement of angle 2 and measurement of angle 3 is the same because they are congruent. All right, so that's going to be x plus 3 plus x plus 3. Then add these up, and I got 5x plus 13 equals 82. And then I have 5x. 5x is equal to 69 divided by 5. So x is equal to 69 over 5, or x is equal to 13.8. All right, a bunch of different ways to represent the answer. You could represent it as a mixed fraction as well. Your choice. All right, NP bisects MNO. All right, so you got to construct a diagram here. I have M, N, and O. NP bisects it. It's P. All right, bisects, so it cuts it in half. Then it says MNP is 7x minus 12. And ONP is 4x plus 5. What is the measure of M and O? Okay. So these angles are equal to each other. So I just say 7x minus 12 is equal to 4x plus 5. So subtract 4x. I have 3x minus 12 equals 5. And add 12. I have 3x is equal to 17. Divide by 3. And x is equal to 17 over 3. All right, the problem's still asking, what's the measurement of angle MNO? MNO, this whole thing. All right, so what am I going to do? I'm going to plug this back into one of the angles, then multiply it by 2, and I get the size of the whole thing. So I'm going to have 7 times 17 over 3 minus 12. All right. Well, these aren't nice numbers. Let's see what we got here. So I'm going to have 7 times 17, which is 119 over 3 minus 12. This is the measurement of angle MNP. Okay. Then I'm going to have 119 over 3 minus 36 over 3, because I'm multiplying top and bottom by 3. Then I have 83 over 3. Okay. And I'm going to multiply this by 2. Okay. Because if I want the whole thing, all right, angle MNO is equal to the measurement of angle MNP plus measurement of angle PNO. So it's going to be 83 over 3 plus 83 over 3. Or just multiplying it by 2. All right, so I have 166 divided by 3. And 3 will go in there 55 times. And I have 1/3 left over. There we go. There's the final answer. Done. All right, two angles form a linear pair. The measure of the larger angle is 4 times the measure of the smaller angle. Okay. Got a linear pair here. The measure of the larger angle is 4 times the measure of the smaller angle. Okay, I don't know what the smaller angle is. I'll call it x. The larger angle is 4 times that, so I'm going to call it 4x. What is the measure of the larger angle? All right, well, I know 4x plus x, these two angles add up to 180. So 5x equals 180. Divide by 5. And x is equal to 36. All right, but it's asking what is the measure of the larger angle? This is the larger angle. So 4 times 36 is equal to 144. Done. 6. All right, two angles form a linear pair once again. The measure of the larger angle is twice the measure of the smaller angle. All right, that's x, that's 2x. What is the measure of the larger angle? So I have 2x plus x is equal to 180. 3x is equal to 180. Divide by 3. X is equal to 60. All right, I want the larger angle. Plug that in. So I have 2 times 60, which is 120. Done. All right, 15. Name the relationship between each pair of angles given. All right, 11 and 15. 11 and 15. All right, here are my parallel lines. That's my transversal. Those are corresponding angles. Okay, 1 and 6. 1 and 6. These are my parallel lines here. This is my transversal. Those are alternate interior. All right, then I have 9 and 16. Those are my parallel lines. That's my transversal. Alternate exterior. All right, and then I have 3 and 6. 3 and 6. Those are, here I have my parallel lines. Those are corresponding. Just as a little side note here, what would these two be? Those would be consecutive interior. They add up to 180 degrees. The rest of them are equal. All right, name all the corresponding angles in the figure formed by the transversal B and lines L and M. All right, corresponding angles, so there would be angle 9 and angle 13. Then there would be 10 and 14. And then there's 11 and 15. And then there is 12 and 16. Done. In the diagram, if measurement angle ABD plus measurement angle BDE equals 180, which segments, if any, must be parallel? All right, ABD plus BDE. All right, so this angle here plus this angle here, they add up to 180. Okay. So if they add up to 180, that tells you something about these two lines here. These two lines are what? They are parallel. So AB is parallel to ED. And that's all there is to this one. Done. Okay, DFE plus BEF plus BEF equals 180. All right, so this one and this one here. All right. Which segments, if any, must be parallel? Okay, well that tells you that these two lines here, because this is the transversal then, these are consecutive interior, so BE is parallel to DF. Done. All right, in the diagram, in order for AB to be parallel to CD, DCB, where's DCB? DCB, this angle, must be congruent to which angle? Well, it has to be congruent to this angle here, because that would be your transversal. You have alternate interior angles. So it would be angle ABC, or you could also call it angle CBA. Done. Those are alternate interior angles. All right, name two alternate interior angles in the diagram that must be congruent for BE to be parallel to CF. BE is parallel to CF. All right, name two alternate interior angles. All right, that would be these two. This one and this one. So that would be angle EBC and angle FCB. All right, for 21 in the diagram, line M and line N are parallel. All right, they're parallel. Put a little arrowhead on them. All right, measurement angle 4 is 3x plus 18, and 6 is 21 minus 6. Okay, what's the relationship between these angles? They add up to 180. They are consecutive interior. So 3x plus 18 plus 21x minus 6 equals 180. So I have 24x plus 12 equals 180. Subtract 12, 24x is equal to 168 divided by 24. And x is going to go in there 7 times. Done. All right, so I have line M and line N are parallel. And 4 and 6, I have 4x plus 1 plus 13x minus 8 is equal to 180 because these are consecutive interior. So I have 17x minus 7 equals 180. Add 7. I got 17x equals 187. Divide by 17, and x is equal to 11. Done. All right, find x so that L is parallel to M. All right, so L is parallel to M. All right, so how do you find the right value of x? Well, let's just say these are what? Are they equal or are they supplementary? Well, is there a relationship between these two angles here? There is not. So whenever you don't have a relationship, there's no name, that means they're supplementary. So I have 7x minus 1 plus 3x plus 11 equals 180. So I have 10x plus 10 equals 180. Subtract 10, I get 10x equals 170. Divide by 10, and x is equal to 17. Done. All right, in the diagram, the marked lines are parallel. All right, got the arrowheads here. They're parallel. All right, measuring angle 1 is 58 degrees, and 2 is 50. Find the measures of 3, 4, and 5. Okay. Let's see, what am I going to do here? Well, what do I know about this angle and this angle? They're alternate interior, so measuring angle 4 is 58. Got that one. What do I know about this angle and this angle? They are alternate interior as well. Or I could say that these here, I'll get rid of this just so you don't get confused. The green angles are corresponding. So measuring angle 5 is equal to 50 degrees. All right, and then what do you know about all these angles combined? They all add up to 180. So measuring angle 3 plus 4, which is 58, plus measuring angle 5, which is 50 degrees, they add up to 180. Okay, so measuring angle 3 plus 108 equals 180. Subtract 108. Measuring angle 3 equals 72 degrees. Done. All right, sketch a concave octagon. Octagon means there are 8 sides. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now, what just made this concave? All right, well, if I extend the sides, the segments, make them into lines, all right, if it doesn't pass, if these lines that I'm creating don't pass through the octagon, then it's convex. All right, so right now it's convex, right now it's convex, right now it's convex, right now it's convex. But right now, I've just determined that it's concave because it passes through the octagon. This shows it's concave, this shows it's concave. All you have to do is apply the test and it be concave once to make it a concave octagon. So there it is. Don't worry about that. Next problem. Draw and label a diagram showing ABC with point D in its interior. All right, here's angle A, B, C. And here's a point D in its interior. Done. Using only a compass and straight edge, perform the following constructions. Okay, now get out of this tutorial and look at the links right next to it to find the links to a construction that shows you how to do this. So see the link. Same thing here. See the link. All right, I have to do a proof here. Statement. Reason. All right. First one and second. AC is congruent to AD. That's given. AC is congruent to AD. All right, so this whole thing, AC is congruent to AD. Then I have AB is congruent to AE. AB is congruent to AE. That's given. All right. So they want me to prove BC is congruent to ED. BC is congruent to ED. All right, let me use yellow for that. BC is congruent to ED. Okay. All right, let's break it down. All right. So I know AC is equal to AD. That's just definition of congruence. And then I know that AB is equal to AE. That's just definition of congruence. Okay, let me get that out of the way. Okay. All right, so 5 now. I know that AC is equal to AB plus BC. All right, and my reason is that's just segment addition postulate. 6. And then I know AD is equal to AE plus ED. That's also segment addition postulate. Okay. All right, what am I going to do for 7 then? Well, using this information up here, all right, I could say that AB plus BC is equal to AD. You could say transitive property substitution. All right. And then for 8, let's see here. All right, so here we have AX is congruent to BY. AX is congruent to BY. And XC is congruent to YC. And I want you to show that AC is congruent to BC. Okay, so here I have my statement. Here's my reason. All right, 1, AX is congruent to BY. The reason, given. 2, XC is congruent to YC. The reason, that's given. All right, then I could go and convert these into being equal. That's definition of congruence. Then I have XC is equal to YC. That's definition of congruence. All right. And then I know that AC is equal to AX plus XC. And the reason for that is just segment addition postulate. And then I could also do BC. BC is equal to BY plus YC. By the segment addition postulate. Alrighty. So what can I do next? I want to show that AC is the same thing as BC. Well, I know that AX is equal to BY, so I could do a little substitution right here. So I'm going to say AC is equal to BY plus XC. That's just by substitution. And then I have XC is the same thing as YC, so I'll do a little substitution there. So I have AC is equal to BY plus YC. And then you'll notice that these are identical here. So I can use the transitive property. Well, that's substitution once again. So for 9 then I have AC is equal to BC. And that is by the transitive property. Alright, and then 10. I'm just bringing back congruence, converting them into different format. Alright, and that's just by definition of congruence. Done. Alright, we have another proof here. So I'm going to put it on the bottom here. Statement. And the reason. Alright, so one, they tell you PF bisects angle APE. Alright, that is given. Then I have PC bisects angle BPD. And that's given. Alright, I have to prove angle 1 is congruent to angle 2. Alright, PF bisects APE. Alright, these are the same. And then PC bisects BPD. These are the same. Okay, we have to prove angle 1 is congruent to angle 2. Okay, let's do this. Alright, so we're going to use some numbers and some letters to describe angles here. So I'm going to have angle 1 is congruent to angle FPE. That's because that's just definition of angle bisector. Alright. And then I know that angle 2 is congruent to angle FPE simply because those are vertical angles. Alright. And so now here I could apply the transitive property. Angle 1 is congruent to angle 2 by the transitive property. And that's all there is to it. Done. All right. One last proof here. Statement. Reason. All right, they tell us JX bisects angle PJQ. So angle PJQ. Okay, so these angles then are congruent, 1 and 2. And it says it also bisects TJB. TJB is this whole thing. So these angles here are equal. Okay. All right, so starting with 1 says JX bisects angle PJQ and angle TJB. All right, that's given. All right, because angle PJQ is bisected, I know angle 1 is congruent to angle 2. That's definition of angle bisector. And 3, I know that, let's see, I'm not going to say 2 and 4 together. I'm going to say angle XJB is congruent to angle XJT. Once again, I know that's because of definition of angle bisector. All right, let's see what I have to work with here now. Okay. I know that the measurement of angle XJB is equal to the measurement of angle 2 plus the measurement of angle 4. All right, and that's by the definition, or I should say angle addition postulate. All right, got that. All right, then I have angle 1 and 3, so measurement of angle XJT is equal to the measurement of angle 1 plus the measurement of angle 4. And that's once again by angle addition postulate. Now you don't have to go in this exact order. All right, there's many different ways we could write out this proof. As long as the reasoning is correct, then you're good. Okay, what can we do next? I'm going to take this statement here. I'm going to rewrite it as an equality. That's just definition of congruence. All right, got that. Now I can do a little transitive property here. These are the same here. Those are the same here. I'm going to do it step by step though. So I'm going to replace XJB here with measurement of angle 2 plus measurement of angle 4 equals measurement of angle XJT. And that's just transitive property. All right, then I'll do the same thing again. I'll take XJT and replace it with that. So that's transitive property again. So measurement angle 2 plus measurement angle 4 equals measurement of angle 1 plus measurement of angle 4. And I just realized I wrote something wrong. This is supposed to be 3 here. That's supposed to be a 3. Okay, now we're good. Yeah, that looked off. Okay, so then once again, that's by transitive property. All right, sorry that this is a bit messy. Okay, so now I could use this information up here. We'll rewrite that as measurement of angle 1 equals measurement of angle 2. That's by definition of congruence. All right. And now I can replace 2 with 1. That's just by substitution. So the last step now is to subtract. If I subtract measurement of angle 1 on both sides, I'm left with measurement of angle 4 is equal to measurement of angle 3. That's just by subtraction property. All right. And the last step is to go back to congruence. So I have angle 4 is congruent to angle 3 by definition of congruence. And my proof is complete. Once again, you don't have to go in this order, but this problem really tests your understanding of how to do proofs and how to apply all the different properties. If you have any questions, please make sure to ask for help. Let's go on to the next problem. All right, if the length of a rectangular plot is twice its width, all right, so width, the length is equal to 2w, twice its width, and the perimeter is 24 meters. What is the length in meters? Okay, so I know perimeter is equal to 2 times w plus 2 times L. The perimeter is 24. I have 2w, and the length is equal to 2w. So I have 24 equals 2w plus 4w. I get 24 equals 6w divided by 6, and w is equal to 4. Take that and plug it in here, and I get the length, which will be 2 times 4. The length is 8 meters. Done. All right, the length of a rectangle is twice its width. The length of a rectangle is like the same as the previous one. All right, if the area of the rectangle is 162 centimeters squared, what is the length of the rectangle in centimeters? All right, so I know area is equal to length times width. Area is 162. I have the length, which is 2w times w. All right, we want to have one variable, then we can solve for it. So I get 162 is equal to 2, w times w is w squared. All right, so I divide by 2, and I get 81 equals w squared. Square root both sides, 9 is equal to w. So I take the 9, plug it in for w. So 2 times 9, the length is 18, and the units, centimeters. Done. For the next problem, find the area of the triangle whose vertices have coordinates 8, 0, 0, 10, and 0, 0. All right, so you could create your own little grid here. 0, 0 is 1 point. 8, 0 is another point. 0, 10 is another point. All right, so here's our triangle. And they want us to find the area. Okay, that's simple. Well, this length here is 8 units. This length is 10. Not much thought involved there. So area of a triangle is half base times height, or base times height divided by 2. So we have half of the base times the height, which is 10. So I have 4 times 10. Answer is 40. And since there's no units here, we're going to use units squared. Done. For the next one, in the accompanying figure, ABC has coordinates 0, 3, 2, 2, 2. Find the area. Oh, that's simple. Okay, so the distance from here to here is 7. The distance from here to here, let's see, starts at 3, ends at 7. So the difference is 4. All right, there we go. Very easy problem. Just have to know how to interpret the data that you're provided with. Base is 7, height is 4. All right, so I'm going to take half of 4 to start with. So it's going to be 2. So I still have 2 times 7, which is 14. And it's units squared. Done. All right, in the accompanying diagram, AB and CD intersect at E. Okay. Measurement of angle BET is 25, and AC is 3x plus 10. They put all that information there for us already. Find the value of x. All right, simple. These are vertical angles, so we set them equal. Done. In the accompanying diagram, AB and CD intersect at E. They tell you 7x minus 12, 3x plus 26. Find the value of x. Same deal as before. Once again, these are vertical angles, so set them equal to each other. Subtract 3x. All right, just do all your work step by step. Often students try to add 12 over in their head, and then they accidentally subtract 12. See it all the time. Just take it step by step. All right, so x goes in there 9 times. We're going to have 2 fourths left over. So x is equal to 9.5. Done. What is the distance in radical form between points 4, 6, 8, negative 2? So this is your x1, y1, x2, y2. Using the distance formula, we have x1 minus x2 squared plus y1 minus y2 squared. All right, so just make sure to plug in the information correctly. So we have 4 minus x sub 2, which is squared, y1, which is 6, minus y sub 2, which is negative 2. All right, 4 minus 8, negative 4 squared plus 6. It's going to be 6 plus 2, which is 8. So I end up with 16 plus 64, which is 80. All right, I'm about to do a prime factor tree to break it down. 20 times 40, 2 times 20, 2 times 10, and 2 times 5. I have a pair of 2's here, and I have a pair of 2's there. So D is equal to 2 times 2, and I have the square root of 5 left over. So it's going to be 4 square root of 5. I'm done. All right, in the coordinates of A are negative 2, 3, and the coordinates of B are 7, negative 1. Find and radical form the length of AB. All right, length means I'm using the distance formula once again. So that's my x1, y1, x2, y2. All right, so distance formula once again. You could call it AB if you like, same deal. Okay, so I have x1, which is negative 2, minus x2, which is 7 squared, plus y1, which is 3, minus y2, which is negative 1 squared. So I have negative 9 squared plus 4 squared. 81 plus 16. So I have 87, 97. And we can't break that down. So AB, or the distance between the points A and B, is the square root of 97. Units. Done. All right, write an equation of a line that passes through the point and is parallel to the line whose equation is this. All right, the lines are parallel, so they have the same slope. So I have y equals mx plus b. Plug in that slope. All right, then I have my x and y value here to figure out my b. So 3 times 1 plus b, 6 equals 3 plus b, subtract 3, and b is equal to 3. take this and I plug it in. So y is equal to 3x plus 3. Done. What is an equation of a line that is parallel to the x-axis and passes through the point 2, 3? All right. Here's my x-axis. What's the equation for that line? That is y is equal to 0. All right, because every single point on this line has a y value of 0. So all I have to do is look at this point here and choose the y value. And that's my new equation, y equals 3. All right, boom. There's the line y equals 3. Every single y value on it is 3. And that's parallel to the x-axis. Done. What is the slope of the line that passes through the points 4, 5, and 7, 3? All right, well, just use the slope formula. All right, so I'm going to have x1, y1, x2, y2. So I have y1, which is 5, minus y2, which is 3, over x1, which is 4, minus x2, which is 7. So I have 2 over negative 3. So it's going to be negative 2/3. That's my slope. Done. 2 points whose coordinates are 4, 17, and 2a. Determine a line whose slope is 6. All right, so that's x1, y1, x2, y2. All right, so I have slope formula to apply here. All right, so I have m, which is 6, y1 is 17, minus y2, which is a, x1, which is 4, minus x2, which is 2. So I have 6 over 17 minus a, all over 2. All right, to get a by itself, I have to multiply by 2 on both sides. Those cancel out. I'm left with 12 is equal to 17 minus a. Subtract 17, I get negative 5 is equal to negative a. Divide by negative 1, a is equal to 5. Done. All right, find the coordinates of the midpoint of the line segment whose endpoints are 2, negative 6, and 10, 4. All right, midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. Okay, so plugging in the information they give me, 2 plus x sub 2, y1, which is negative 6, plus y sub 2 over 2. All right, so I have 12 over 2, and then I have negative 2 over 2, which leaves me with 6, negative 1. Done. All right, what are the coordinates of the midpoint of the segment whose endpoints are negative 4, 6? Negative 8, negative 2. All right, so I have x1 plus x2 over 2, y1 plus y2 over 2. So x1 is negative 4 plus x2, which is negative 8. Then I have y1, which is 6, plus y sub 2, which is negative 2. Negative 4 plus negative 8, I have negative 12 over 2. 6 plus negative 2 is 4 over 2. So I have negative 6 and 2. Done. All right, the midpoint of AB is M. If the coordinates of A are 2, negative 6, and the coordinates of M are this, that's my midpoint. Find the coordinates of B. Okay, so B is going to be my x2, y2. Alrighty, so I have my slope formula, not my slope formula, my midpoint formula. plug in all the information I have. So I have x1, which is 2, plus x sub 2 over 2. y1, which is negative 6, plus y sub 2 over 2. And that's equal to the midpoint, which is 5, negative 1. All right, so I'm going to have 2 plus x sub 2 over 2 equals 5. And I have negative 6 plus y sub 2 over 2 equals negative 1. So I'm going to multiply by 2 on both sides. So I have 2 plus x sub 2 equals 10. X sub 2 equals 8. So multiply by 2 on both sides. And I get negative 6 plus y sub 2 equals negative 2 plus 6. And y sub 2 is equal to 4. So my answer then is, for point B, the coordinates are 8, 4. Done. The coordinates of the midpoint of AB are 6, 8. All right, that's my midpoint. And the coordinates of A are 3, 2. That's my x1, y1. Find the coordinates of point B. All right, point B would be x sub 2, y sub 2. All right, so there's the midpoint. Formula, x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. Plug in the information that I was given. So I have x1, which is 3, plus x sub 2, I don't know what that is. Y sub 1, which is 2, plus y sub 2 over 2. That's equal to the midpoint, which is 6, 8. All right, so I'm going to have two equations now. So I have this one. I have 3 plus x sub 2 over 2 equals 6. And I have this one. I have 2 plus y sub 2 over 2 equals 8. So multiply by 2 on both sides. I have 3 plus x sub 2 equals 12. Subtract 3. And x sub 2 equals 9. Multiply by 2 on both sides. 2 plus y sub 2 equals 16. Y sub 2 equals 14. All right, so I have B, which is 9, 14. Done. Lines L and M are perpendicular. If the slope of line M is negative 4, 3, all right, then my new slope is going to be the reciprocal of that and the opposite, so it's going to be positive. What is the slope of the line L? Oh, I already answered the question. Done. All right, if the slope of JK is 3, 4, or 3/4, and JK is perpendicular to PQ, what is the slope of PQ? Okay, well, all I have to do is flip that and include the negative, the opposite. And that's all they want in this problem. So there's the answer. We're done. If you have any questions about anything, please make sure to ask. The benchmark is a very important exam. Students often ask me, is the benchmark hard? And my response is, it's as hard as you made it for yourself. All right. Have you been putting in 100% effort? Have you been asking questions? Have you been completing the assignments on a daily basis? I don't know. Only you have the answer to those questions.